Hey guys, here's another update on the magnetic paddle shifter. I am ready to post the plans. So in this video I will show you how to assemble one of the units. I've created a second type. The original one was using one of these switches with a metal lever on top, and I've looked up the data sheet and they're not as reliable as the version without the lever. This new design uses this lever will push directly onto this button, and it makes it much more reliable. How reliable depends on the switch or on the manufacturer. So if you order a high quality part, it's going to last a lot longer. This design, I will post both plans. This design still works, but for my own system I will be building the unit with this type of switch. So let me get this out of the way. This is the old design, or it's still working, but I won't be using this from my setup. Now this one came out of the printer and I did some basic cleanup. Removed some of the strings, but this is still, depending on how accurate your printer is, you're going to need to clean it up a little more. So you can see if you push them together, they're binding. That is not good, but I've created the tighter tolerances so you don't have any slop once you assemble the unit. So what you need to do is just remove a little bit of the components. Also in here, this is not smooth because the 3D printer prints and just puts down a loop of plastic for each layer. So you have a little bit, it's uneven in here. And then this plastic part rubs and it binds up. So we just need to clean this up a little bit. Oh yeah, for printing, this part is built with metric units in mind, and you should use probably a layer height of about 0.25 millimeters. That's what I'm using for all my parts. Takes a little bit longer to print, but you get a nice result. So to start, I'm going to start here. If you just feel it, you can feel the little layers. So all we need to do is just go in here and just smoothen it out. Doesn't need much, and just after a little bit I can already feel the difference. Big difference. And just make sure you do this alongside this edge here and over here, and then later on we'll be cleaning this one up a little bit as well. So let me just do this real quick. And also go along the edge, because now that we've removed some parts, the plastic gets a little warm and you usually create a little lip. And that could bind it up as well, so make sure you remove that. There we go, that feels good. And then the same thing on the other side. This may actually fit much. It's already going in easier. Same thing under here. The way I print this part is I'm printing it standing up like that, and this is like this. So on the top, usually on the bottom side, nice and flat because it's on the print surface, but the top side is more uneven, so make sure you spend a little more time with this. And then also the design without the lever, make sure that this inside here is smooth. There's a little bit of a lip here that needs to go away because the tolerance is the way that switch is, the button here is really small, so if you have too much material it may never release the switch. So let's just go over this part as well. Make sure this is smooth. And then same thing, go along the edge real quick. Make sure. Okay, let's give this a try. Okay, it's already fitting in much better. There's a little bit material left on the top here, because in here now it's moving freely. It's probably not going to hurt anything, but I'm still going to clean it up. And that depends on how accurate your printer is, how well it is set up. You may not even have to remove anything. I've recently switched printing programs to Octoprint. While the overall print quality has gone up, it messed up my dimensions a little bit. It's not quite as good anymore. Or, well, it's just a little different. I still need to play with the settings. Okay, let's give this a try. There we go. Okay, so now it's moving freely. Same thing up and down, so it shouldn't stick. Make sure you test this once we have the magnets in place. Make sure it doesn't bind. If it does bind up, just take it apart again and remove a little more material. Okay. There we go. Now these here are the pockets for the ball bearings. For that, let's see, this is a 5mm, 4mm. It's just a 4mm wood drill. I'll just go in here, turn that a bit, clean that out. A sharp knife helps as well. And make sure that the channel that goes through here is clear. That's probably the best way to do it, is just take one of these, what are those, M2? Yep, M2 screws, and just put one through. There we go. The channel is wider, so you shouldn't have any problems. This just goes straight through. Now at this point, oh no, let's clean this first. Very important, you need to make sure this is clean. This is where the switch goes. This is a switch pocket, and they're just little, tiny little plastic dots. They need to go away. Otherwise, the switch will not go down all the way, and then you're going to have problems releasing the switch or even pushing it. So pay close attention to that. This is really important. And just remove that. To this design I also added a little back plate right here, so the switch will sit in here and it can't slide out. On the old design it was just held in by the lever. Once it goes down it fixes it in place, but everything is a lot tighter with this kind of switch, so even if it moves back a little bit it's probably not going to work as well anymore. So just some design improvements. Small piece, there we go, that should do it. Just try it out with this switch. And it should fit right in here. Nope, not yet. Now, this type of switch, the way it sits in here, it will not go all the way down. It's going to stand up a little bit. So don't try to force it all the way in. It will not. It'll always sit just a little bit above this top part. There's a little lip here. That's fine. That's what it is. Okay, at this point I would go to the bathroom real quick and wash this off, because you have little plastic dust all over the place and you definitely don't want to get this into the switch. So I'm going to cut real quick and I'll be right back. Okay, now that this is cleaned up, I'm going to start with this part and just add the ball bearings. Now the ball bearings are not used properly in here. Usually you need to make sure that you only load, that the load is on the inside, that the load is on the inside of the bearing, but this does not spin like a motor, it doesn't spin much. You could probably also, instead of using a ball bearing, you could get a hollow steel tube, force the tube through here, maybe use a drill to drill it out a bit, so that the screw isn't riding on plastic. That's pretty much all those ball bearings are doing. It's just a steel part on both sides to ensure that the lever only sits on 2 points. Whereas if you could even use, well, I don't know, no, probably not with this type of switch. It would work, or it will go up and down without a ball bearing, but it just keeps everything in place and it makes it tighter. These ball bearings are really cheap. You get them off eBay or Amazon. Like I said, they're not used properly, but they really improve the part. It makes everything much smoother. I've been using the same type of bearing for all those tests and I haven't had any issues. So let me get those in here. And also inserting them, usually you need to make sure that you, what I'm going to do, I'm just going to bang on them and force them in there. That is not the proper way to install a ball bearing. But again, we don't need the operation, it's just a steel part to hold it in place. Let me just get something to whack it with, hold on. Okay, there we go. Make sure it's straight. And then carefully tap it in. Make sure it's flush. Very important. And the other one as well. This is not exactly, not perfectly round. Oops, magnet sticking. Yeah, make sure the hole has the proper size. Sometimes this is the bottom layer that was on the build plate, and since it's the first layer, they usually on the holes you just have a little bit of like plastic, like a plastic lip. And just make sure that's gone before you try to force the bearing in. Oops, stay here. Yeah, see, that one fit. So let's just open this up a little more. Come back. Let's see. Yeah, it'll set itself. Nope. There we go. One more. Two more. That's it. Perfect. Now at this point, there are tiny little balls in the inside, or actually rollers in the small one. It's not good for them. Like I said, this is only so we get our axle through. See, now it just rides on the screw itself. That's all it needs. It's not going to turn hundreds of RPMs. It's just small operations, and it makes everything much smoother. I've tried it without, and it does improve the feeling and operation. Okay, so now this is done. Next up, the switch. Just great neighbor coming by. Solder your wires to them. And there are little wire guides in here. So just stick your wires through. And the way this needs to be oriented, the button needs to go towards the front. Don't do it like that. That works with the lever type, but if you use the button type, it has to be button towards the front. And push it in all the way. Make sure it is in, but keep in mind it will not be flush with this top plastic part. Okay, let's see if you can see it. It's just going to sit just a tiny bit below this lip. This lip here, make sure that the lever doesn't actually hit the switch. So the switch needs to be just a tiny bit below that. Very good. Now, if you're going to install it, make sure that you screw it in first. Now, this is just going to be for testing right now. Put the part in, make sure it's lined up. There we go. Oh, wait. Forgot one step. Still some water in the part. Get the M3 nut, no, M2 nut in here. And this one you can just press into the part. Need more force. There we go. Okay, I'll just put this in here. Make sure it's aligned. You can just look through the hole. There we go. And now we just need to screw this in. Oops. Yeah, I should have opened it first. Make sure the screw actually goes through. Give that a try. There we go. Yep, there. Okay, I'm just going to screw this in once. That's probably a good idea to do that before so you don't push any plastic into this channel, because there's going to be a little bit of plastic left in this hole. If we screw that in first, it's going to push it out. See, it's not going in because there's still a little bit left. And the part is pretty thick, so it's a little difficult to cut it out. So on this side. And then make sure that you remove any plastic that came out of the hole, because it'll just bind up. There we go. Try that again. Yes, much better. Oh, I hate flathead screws, but in this size you really need to use them. There we go. And now just screw them in. You could also use a small drill, just open up the hole a little bit. It doesn't matter if the screw is a little loose, just don't make the hole too big. And then, actually, it's a good idea to try that first, because I've had it once where there was a problem printing and this wasn't aligned properly, so it didn't fit. But here, yep, and it goes into the nut, very good. And you can actually tighten it. Be careful, don't over tighten it, because this is one of the issues with 3D printing. The part is not going to be strong in this direction, because it's just layer on layer on layer. So if we clamp it down too much, it'll probably just separate right here. That's why these are thicker, so they can take a little bit of stress, but don't overdo it. Once you hear it cracking, you know you've overdone it. Okay, screw goes through, perfect. So let's just take it back out. And at this point, it's much easier, since we have thread in it. Just take it out like this. Okay, now again, make sure you remove any of the plastic dust that just came out. Very good. Nope, doesn't align. Make sure. Let's see. Okay, and if you hold it up against the light, you can look through, and that works. That's not aligned. Oh, that's too high. It moved up. There we go. Yeah, now it's in. Perfect. Okay. You probably should add some Loctite to this or get a locking nut, because I can imagine once you have it on the rig with all the vibration it's going to come loose. Don't over tighten this. Once you over tighten it, it's going to be hard to move. So just back it out until it's free to move. There's some binding left. Where is it catching? Right on this side. I have to take it out a bit, and take it out again, and remove a little bit more material. Alright, it's this corner right here. Looks like it. Hold on, let me close the window. Okay, that should help keep the noise out. Again. Oops, there we go. That's better. Yep, just a little bit of material, that helps. And I prefer doing it that way instead of designing the part much too big, because all the printers have slightly different accuracies, and just remove a little bit by hand. Overall, it's going to be a tighter part, better fit. Okay, let's give this another try. Make sure it's aligned again. Very good. Could probably go a little over or a little more, but this should be fine, at least for this test. It'll also wear in a little bit, but before I'd install it on my own system, I would clean it up a touch more. But this is already working quite well. That's why I'm doing it on the video, so you can see there is a little bit of preparation. There's a little. This is do it yourself. There is a little bit of modifications you have to do, but overall design is working quite well. Okay, now the magnets. Oops. These are standard size, 12mm diameter, and 3mm thick. You can use thinner ones or thicker. That will depend on how strong you want to have it. I've noticed that the 3mm is a really good size. Just put one in the pocket down here, and then make sure, just let it fall in by itself so you know the orientation is correct. Okay, there it is. And then push it into place. Now you shouldn't have to glue this, because the two magnets will just attract each other and keep themselves in. And make sure, it's sometimes a little difficult because now they're pulling each other up. You need to make sure the pocket, probably some plastic in the pocket as well. Clean that out. Now it should just fit, in. There we go. Perfect. There it is. And you see, it's still catching on the lip. I'll have to, yeah, it's still this one side. I have to clean it up a little bit. Okay, so I removed a little more material. So now there's really nice and smooth operation, no sticking. What I will do before I post the plans, I will make the inside wall just a touch smaller, probably like 0.25mm should be enough on both sides. So you're not going to have to remove as much material, if any. This is how it's supposed to be. There will be no sticking. It's all very nice, smooth, and fast return. So at this point, the switch is assembled. Now we need to make sure it actually works. So I'm just going to use my multimeter here real quick. Oh, is that right? See? Very nice and smooth and fast. And this is how it's supposed to be. Now this design over the one with the lever, what I've done is I've reduced the throw so it doesn't go down as far anymore, and also the switch is activated sooner. It's about halfway in between hitting the stop and when you push it. Now if you have some trouble during assembly, let me show you real quick. This is all the dimensions inside, and when the switch is pressed, it's all very tight. And the nature of 3D printing is that it's not, or the current versions anyway, or home printers, they're not as accurate. So if you notice that your switch doesn't work or it's getting pushed all the way, remove a little bit of material from this lip. Not much. Right here in the beginning. This is where this button rides on or gets pushed by, is this piece right here. And if you notice it's being pushed in without you pushing the lever, just remove a tiny little bit of material here. Not much, just a little bit. And then just move a little bit, give it a try, put it back on, and remove a little more. Also make sure that this is seated properly. Let me... Where did that? There we go. The height of the switch, right where the lever... zeroed. Where the switch is supposed to be 1.2 millimeters above the surface. Make sure the other side too. Yep. So about 1.2, 1.25, somewhere in that range. So make sure this is in all the way, and then if it's still being pushed, just remove a tiny little bit. Don't need much. And see also now that the proper amount has been removed, this just slides in real nice. It's still a little tight up here, but it doesn't matter because that's not where it rides on. This is where it needs to be. Nice and smooth. So let me get this back together. There we go. And that is the paddle switch, the shifter. With that, I have those 3 printed paddles. I attached them right below. And in the tests, they've performed really well. There are aftermarket carbon fiber paddles. I don't know if it's necessary. These are really strong. And I think they're only printed with like 20% infill. You can see the holes. This is all air. I've ordered my OSW today, so it'll be here by the end of the week, and I'll know for sure how well they hold up in a very short time. Keep you posted. I will post the plans along with the video. Let me know if you have any questions or if you have any suggestions once you print them. If you run into any issues, you can contact me through my website. YouTube comments usually not the best way to do it because responding in that comment section is just bad. So, or GitHub page, of course. The plans will be posted on GitHub, so you can use there's like a bug reporting function. You can use that as well. So, plans will be posted later today along with the video. If you're interested in building that, just need a 3D printer. That is somewhat accurate. I would suggest printing in 0.25mm layer height. This part right here is printed with 20% infill. The lever itself, I also set to 20 or 25%, but it doesn't matter. The slicing software just made this solid, which is probably a good idea anyway. Other than that, well, this is it for that. If you have any questions, let me know. Bye.